you, Dr. Washington. We are truly excited today for our seminar on advancing data science in K-12 education. We have three esteemed guests that are joining us today, and I've had the opportunity to work with each of them personally, so I know they're going to bring much to this conversation. We have Miss Andrea Wright, who serves as the STEM coordinator for DeKalb County Schools, who's done amazing work across the schools integrating data science and STEM into the curriculum. We've had the opportunity to collaborate on several opportunities where we are connecting higher ed and K-12, and Mr. Laron Walker, who owns an educational technology company, MantisEDU, among other education and outreach organizations, along with his tech companies. He's a computer scientist who I've had the opportunity to collaborate with on data science and other technologies that promote STEM learning. And then lastly, we have Dr. Troy Washington from Marquette University, who's the co-director of the BLEST Hub, and he does work with data science and actually looking at school discipline, restorative justice practices. So each of them are going to give a short talk. We'll start with Ms. Wright from DeKalb County, and then we'll have a question and answer session with each of them. We'll have our engaging conversation around the future of data science in K-12 education. So Ms. Wright, if you're ready, we'll go ahead and allow you to start our first conversation. Thank you.
Well, good afternoon, everyone. I'm excited to be here, and thank you to the AUC data science team for inviting me. I am charged with talking to you about the K-12 perspective, and I chose to go with STEMming with data because STEM is my space. So I am Andrea Wright, the district STEM coordinator for DeKalb County School District. And I'm going too fast. Y'all are getting a preview. Here we go. So if you don't know anything about DeKalb County, we are the third largest school district in the state of Georgia. And I know we probably have people here from all over the world. We are the 28th largest school district in the country. We have 138 school centers, service over 92,000 students, and our babies speak over 160 languages. So when you think about us, think about a mini United Nations of scholars. What you have on the other side is you have our fact sheet. It's pretty current despite the date at the top. What you have on the other side is a snapshot of what's happening with STEM and STEAM in DeKalb. We are unique in that we have 33 certified schools. And as part of the Department of Career, Tech, Ag, Education, CTAE, and other states that you'll hear CTE, we have 17 career clusters that span middle school, high school, and that breaks down into 40 different career pathways. We have partnerships with a number of the major industries, colleges and universities, and we try our best to expose our babies to ideas and careers and opportunities that they may not have historically had. So from the high level view, the state of Georgia is really big on STEM. We have new math standards that have rolled out. And as part of the math standards for the state of Georgia, they built in data and statistical analysis all the way from kindergarten to high school. So what it looks like is a progression of exposure from calculating data and information to analyzing it all the way through and how they're going to represent that. Our current superintendent is really big on data. Historically, all of our superintendents have pushed data disaggregation, and our current superintendent, Dr. Devon Q. Horton, has taken it to a different level. So we might have done Gallup surveys in the past, but you'll go on our website and see or we're having deeper talks about the survey results and using that to inform the work of our district. He introduced thought exchanges. So we may be given a question and it almost feels like a discussion board, but then that information is flipped and used to inform some of the decision making in our district. And then outside of that, we've had advisory councils in the past, but like I serve on the superintendent staff advisory council. He also has a bilingual parent council to make sure that there's equity and diversity of thought and conversation, and student council as well. So Dr. Horton is listening to input from all levels of stakeholders across the DeKalb County School District. And then as a district, of course, we're analyzing school data down to library circulation and how many books get checked out and all sorts of other things. Even tracking bus times and making sure that we are efficient and effective. So when looking at what our children are doing in schools, you'll see a broad mixture of things. On the screen, you'll see monarch migration. We have students at Sagamore Hills. Second grade students have built and planted 3 pollinator gardens, which have been certified by the National Network Monarch Watch. Then some of their work has also been included in the Rosalind Carter Butterfly Trail, and they have committed to planting new pollinator gardens across Sagamore Hills every single year. Third graders include monarchs as part of their curriculum, and fifth graders are studying monarch DNA to determine which specimens are healthy. And then we're also tracking monarch migration to Mexico and working on other citizen science projects with people around the world. The other images on this slide are from our Minecraft. Minecraft is huge in DeKalb County. And for those of you who don't know, Minecraft is basically a virtual space where you can build a world from scratch and imagine the space any way you want to, but you're building block by block, even down to the little people. So what you see is Liza Lucas, who is a news anchor here in Atlanta on Channel 11. The Girls Who Game Club at Briar Lake Elementary built out this space for the community, and it is a virtual space in Minecraft that provides supports for citizens to know true and false information in the digital world. And they had to research and interview community members to improve their design. As part of all of our Minecraft challenges, we try to include conversations with community experts to refine our thinking, and also the kids are presenting to them as well. In the lower photo, you'll see a picture from our Girls Who Game summer program. And for that program, we have all middle school students. They may or may not be from STEM and STEAM schools. They come from all over the district, and this may be the first time they've been exposed to the concept of STEM and STEAM. For those scholars, they work with scientists at Fernbank Science Center and also have expert interviews from people in esports, people from Dell, Microsoft, the local community. A variety of experts talk to them about their careers, their jobs, and they use that information to create a virtual space in Minecraft. But their challenge has been unique in that after talking to the scientists at Fernbank, the girls reimagined what the Fernbank exhibitions could look like. And all of that's done in collaboration and partnership with stakeholders. Here you'll see something we do every August, the Great Southeast Pollinator Census. Kids are collecting data on the pollinators they see in the various school gardens or outside, even if they don't have a garden. They're looking at how many insects and bees land during a certain specific time. This is, again, another citizen science project where kids are sharing their information and data with people from all over the world, but it's in partnership and collaboration with the University of Georgia. And the goal is for kids to think about, and everyone to think about, how we can make a difference for pollinator conservation by recording and sharing data. Here you have a snapshot from Tucker Middle School. They are working on a solar powered energy PBL. And what they've done is chosen buildings in the community and spoken to the owners or different companies to talk about their energy usage. And they're challenged with figuring out where they can put solar panels on the specific buildings and locations. So for one example, one team is trying to figure out how they can put solar panels on Stone Mountain Park. Where on the mountain can we put solar panels where it will provide usage to reduce economic costs and energy consumption, but also not be visually, I don't want to say disrespectful, but aesthetics. We want to make sure it doesn't hinder the aesthetics at the park. They looked at energy consumption, how much is spent. They're also calculating the cost of what the solar panels would cost for installation, for shipping, taxes, like all the nuts and bolts. And then they've flipped that into a presentation. Some of them had choice because we're big on choice and voice in our STEM schools. Some of them had choice in how they would present the information. So you'll see that some of them created it in like a Minecraft type space or in Tinker. So they're using the technology to communicate and show what they're learning in class. And then you'll see snapshots from our social media. Under our CTAE pathways, kids are exposed to business and entrepreneurship. They're exposed to higher levels of coding, robotics, computer science. They are learning how to be future business leaders and presenting and running their own companies and learning how to run their own meetings. And then our kids are competing in so many different things, whether it's drones, which we're competing in tomorrow, a drone competition, or Vex Robotics or First Lego League. We're doing things that expose kids to that computational thinking and problem solving from pre-K and kindergarten all the way to 12th grade. So the goal is that kids will be successful when they leave us, no matter what they choose to do, whether they go to the military or college or to industry, they're ready. And that's part of our goal. So we're always looking for ways to bring learning to life through realistic connections and rich thought partners. And that's where community members can help us. So with all of our schools, think about problems and projects that you're working on in your labs or in your classrooms or as part of your research. Share those ideas with us in schools because the kids need to solve real problems. They need ways that the learning and the content can come to life. In STEM schools in particular, they're tasked with collaborating and working together and putting the phones down or using the phones to create if they're creating an app. But the teachers have to collaborate. The teachers have to be confident in their content in order to make sure that what they're teaching not only meets the standards, but brings the learning to life. And that helps when we have collaboration and conversations with people outside of the district. Share your gifts at career days. I did a lot of posting on social media asking for people to come to career day this year. Competitions like our underwater robotics competitions. We're always looking for people to look at the kids' work and give them feedback. And also we're always looking for judges to participate in fairs. We also need to know what expectations you all have for people walking in the door, either in your classrooms or in your schools, in the workforce. What are the skill sets that they need? So some of that happens as part of our advisory boards. So schools have advisory boards. We have CTAE advisory boards. We have a lot of advisory boards coming where you can share your knowledge and input, especially when it comes to what's happening with AI right now. So feel free to stay connected. If you're curious about all the different things I showed you as a snapshot from social media, we are on for DCSD STEM. You can follow us on Twitter, which is now X, IG, which is Instagram. And also Threads, which is the newest one. We're on all of those different platforms. And feel free to connect with me. I'm on Twitter as well as LinkedIn. So thank you. If you have any questions, drop them in the chat or Q&A, and I'm here for all of it.
Thank you so much, Ms. Wright, for that insightful view into what's happening in the DeKalb County schools, truly with the insights around realistic learning and partnerships in the community. There's so much value in community connections, as you highlighted. And please reach out to Ms. Wright if there's any way that you can support the work that they're doing, because I know that we've had several wonderful conversations and been able to establish many fruitful partnerships with the district. So thank you for joining us.
You're
All right.
welcome. And I'm sorry, Justin, real quick. And it's not just about connecting with us, but connect with schools in your community and your neighborhoods. If you're outside of Georgia and across the globe, it really does make a difference. Thank you.
Yes, thank you. And next up, we have Mr. Laron Walker, who is the CEO of MantisEDU and Cyber Technologies. He's going to talk to us about some of the school um, partnerships that he's helped to establish and work that he's doing around integrating data science, computer science, and STEM into schools. Mr. Walker.
Thank you. What are you doing today? Thank you for taking the time. Let me share my screen. Okay, let me see. All right. Okay, you see the slide okay? Some of you guys see the slide that I'm sharing. So yeah, thank you for taking the time, and I do appreciate it. So I'm Laron Walker, Atlanta native, product of Atlanta Public Schools, and today I serve as a tech entrepreneur and also a philanthropist. And so STEM is part of my why. My background, I attended Atlanta Public Schools, Tennessee State, and ultimately Purdue University, where I studied electrical and computer engineering. And my story is that I learned how to write code, and it changed my life and it changed my family's life. And so a big part of my why today is making sure that students and learners are able to really get hands-on learning through STEM and find ways to apply it toward whatever their career aspirations are. So that led to me starting a company called MantisEDU. And MantisEDU is a net tech company where we build and create STEM solutions that people who serve youth leverage to support their educational journey and pathway. And so our big portion, as you just heard in the previous conversation, is finding ways to make sure that students are exposed to real world problems through hands-on learning that's engaging, while also allowing for them to kind of build skills that they can use in the workforce, no matter what their career aspirations are. So whether you want to go to college, you want to get a skill, you want to become an entrepreneur, our goal is to expose you to these things in ways that are meaningful, that drive value. And so we do that in a couple of ways. I partner with my nonprofit as well, and we run a lot of programs that are in schools, we're in churches, where we sell direct to consumer, but most of them kind of follow this paradigm. And I know that the nature of this conversation is around data, but oftentimes you get that question like, how and why would I use this? And so one of the things that we've done is we built these turnkey ecosystems that allow for that to happen. And so oftentimes we have some kind of a sensor or manipulative that's kind of collecting data. There's some software platform to let you allow and manipulate that data. And then we build these really cool, interesting scenarios where you can take that and deploy it to applications so you can kind of see things work. And we do this across a number of modalities. So whether you are an early learner who's, elementary, upper elementary, middle or high school, we, change out our environments to ensure that particular student or person can have success. And so I heard earlier, we mentioned, think of make code and scratch. So if you're a young kid, you want to come in and get exposed to these tools. A lot of our kids are being exposed to these scenarios, but oftentimes what they're doing is really, let's say, maybe they animated or made a video game. In our case, we've actually taken these solutions, whether it's Scratch or Make Code or the things you've done, and we've done real-time connectivity. So now a student can come in, and there's a robotics platform, they can use whatever the tool of choice is. And so they can graduate from Scratch, Make Code, and they may go to Python or JavaScript. And we'll run camps or after school programs or even things in the classroom that are aligned to standards to allow them to kind of experience these tools to where the outcome of the standard is the goal, but the tool that they're using to leverage it can be differentiated based on their background. And so we spent the last, I would say, 10 years or so building this platform out, and we have a wealth of resources that kind of come within that ecosystem to allow for them to deploy that. And so, and then for older kids, when you get into more scripted languages, whether it be, tools like whether it's Python or R or JavaScript, we then take those same examples and build those inside of the same environment. So again, we can go from the early learner to somebody in post-secondary and allow for them to put these in place. And then whether you're a school, a district, or a youth provider, we provide you with a turnkey platform and content, curriculum, and training to push that forward. Within that, we build a number of really cool sensors that we manufacture to make things interesting. And so here's an example of one of our sensors. This is our climate tag. And the cool thing about the climate tag is that it creates a lot of data. So this particular sensor measures light, temperature, humidity, pressure, all in real time. And so as an example, one of our partners, well, two of our partners offer this as a course around data science and anomaly detection. So we have a course where kids learn about IoT and Bluetooth. They learn how to build apps to collect data. They learn how to put data into various formats, whether it be, a CSV file or a JSON file. But one of the outcomes of one of our more extended courses is that it's an entire course on anomaly detection. We run experiments where they collect data, they look for outliers, then they use machine learning through Python to predict what's going to happen based on certain conditions. And so it's a really cool way to allow for students to, collect their own data sets and see the cause and effect happen. So that's one example. Another use case that we have with this particular sensor is that it's really been used a lot in intelligent gardening. And Dr. Ballinger and I have done a lot in that particular case where people will take this sensor, they'll put it into greenhouses, and they'll monitor data over time and use that to kind of make decisions on what's happening with that. And so really cool opportunity, but that's one of our sensors. Another one we have is our moisture probe. This one is really cool with plant sciences. So one of our courses is a course on cause and effect. And so we'll go through an entire scenario where kids learn about data, how much water or, is needed to perturb plants to have them kind of achieve a certain outcome. Then they use data science analytics to build a smart watering loop to be able to monitor and make sure those plants have a healthy life cycle. And depending upon their skill set, student may focus on the software aspect of that. They may look at building the environment, or they may choose to build the mobile apps or the dashboards used to kind of guide that system, throughout its life cycle. And so there are a lot of cool ways to interact and leverage that. And then we have our MODI sensor, which is almost like a Fitbit on steroids. So think of a gyro, so motion, acceleration, and distance. But this particular kit is really cool for data science in that we use this to do things like if you're teaching like physics examples, you want to do things like show how velocity corresponds to distance or velocity. They use math and science to figure those things out. But more importantly, we use this a lot for building predictors, right? So am I walking? Am I running? And so we're soon to build another sensor where it'd be a data science wearable where kids get access to real data. Because if you think about it, your Apple Watch or Fitbit, that black box is kind of unknown to you. You can't get that data. And so this gives you access to their raw data. And we're using this now to build programs where kids can go and do things like if they're into sports and they don't understand the connection between sports and data, what if a kid could take a sensor like this and build a basketball wearable to determine if you shoot like Steph Curry, right? Or a football wearable to determine if you're running fast or slow, or a track wearable to make sure your gait is proper as you're doing the 400 or 200, right? So these type of sensors allow for those things to happen in a hands-on way. Excited about this guy. When you get into robotics, I heard Ms. Wright mention robotics. And so that's a really cool place. But oftentimes expense and utility in that can be really limited in some of the communities that we care about. So this is an example of our robotics kit, that's EV kit that's built from parts you can literally find in Home Depot, right? And we teach kids about 3D printing, additive manufacturing. They build this from scratch. And then they use our various software tools to control and do things with it. And so one of our schools, they built this out, and they built a garden rover to navigate autonomously around their garden to be able to focus on ways to detect if their plants were healthy. We had a few interns this summer that were high school kids this summer where they brought in cameras and we taught them how to use machine learning to detect, hand gestures. So one kid, he used our AI engine to help him determine sign language for, signing like left, right, back, forward, stop, go. And then he built a real-time connectivity engine that could drive the robot using sign language and focuses on the hearing impaired. And this was a high school senior doing it as a part of his capstone project. So again, a lot of ways there to bring data into the fold. This is an example of the smart plant kit. We actually use this in both after school as well as in classroom experiences where we were co-teaching with a couple of our partners as a PBL, as a part of the classroom, where they actually built these kits, used them. And in one of our partner schools, a lot of kids took it to this, they used this as a part of their science fair to kind of show examples, right? So it's really cool ways to have hands-on and bring data to the fold without kids really understanding or not understanding why things are happening. So those are some of the core things that we're doing. And I just wanted to show a few more things, like when I mentioned that rover kit and how you apply data to it. So this is that exact kit I showed before. And since we built this kit, it can go in different ways, right? So we expose the full 3D models so kids can understand how you build this. So they literally build this, like I said, from scratch. So I can explode this model and you can see all the parts that come with it. But then we provide all of the printed instructions to put it together, all the videos to put it together, but the math and science is farther down. So in this case, if I wanted to go build, let's say I was doing a course on JavaScript, here's sample code where we show them how to use JavaScript to control this using web Bluetooth, and we can provide all the code for doing that. But there are also examples where here's an obstacle avoidance example using JavaScript, or an obstacle avoidance example, using Scratch. And so in every example, we build out really good examples to push that forward. We also have a smaller robot that I didn't show in the presentation for some reason, but it's called our Mantis Scout. And this is a smaller robot that's used for younger kids. Now, the cool thing about this one, and I pulled this up in particular, a lot of robots have things like sensors, like RGB sensors or LED sensors. But typically the science is, hey, have the robot blink a color. In this case, to give an example, we have this color block swatch that shows up. And this block swatch is, you can see the different colors that are here. The nice thing about it is that what happens is that in that example, a kid is in Scratch using this solution, but we actually notice that we're using math and science. So we're teaching the kid Pythagorean theorem. They're using that to use the RGB sensor to determine which color blotch is closer to the color they're currently reading. So we're showing them how to use math and thresholds and science to determine what color I'm looking at. So we really focus a lot on making sure that you're applying science in a way that makes sense to understand utility around it that can be applied to applications. And so all of our things kind of go down this path and really make it hands-on. And a couple more things that I'll show. Here was an example of a short course we did during COVID. A lot of things we do also happen, virtually, but I just wanted to show you how this was using that environmental sensor. And in this video here, here you can notice that the next screen you'll see here, this is literally kids collecting data, saving data, building the anomaly detection algorithm, using charts and graphs inside of the presentation in real time. So really hands-on stuff, again, using isolation forests with data they collected, being taught by a master instructor who has a PhD in this industry, and they're actually building this stuff in real time. And so I'll pause with that and stop talking for now, but just wanted to kind of share with you guys our approach. So how do you take and build content out? How do you make sure that the content is hands-on and important and hands-on? And then make sure that people who are teaching our kids about data and science are able to show them why it works to get them excited to move it forward. And so with that, I'll pause, Dr. Ballinger, and hand it back over to you.
Excellent. Thank you so much for joining us, Mr. Walker. It appears that Dr. Washington, Troy Washington, was supposed to join us, maybe having some technical difficulties, so he will not be able to join us this afternoon. So that's going to start our question and answer session a little bit early. So please feel free to add questions to our chat so that we can ask questions of our esteemed panelists who shared so much about the amazing work that they're doing. But what I'll do while we're adding those questions to the chat is I'm going to include a couple of, I'll ask one question to our panelists while we're waiting for the questions to populate. And that is, what excites you most about the future of data science in K-12? And we can start with you, Ms. Wright.
Sure. What excites me? What excites me is that from what I'm seeing, the intersection between all the contents is a really cool spot to be in, because kids and adults are not just learning math in isolation or learning computer science and those skills in isolation. I can see how all of these things overlap and can make a huge difference. And it also is cool because some people are really good in this space. And before they may not have felt like they fit in, they might have been just a math geek or just a tech geek. But this space, you can do so much with it from what I've seen and from looking at you all's webinars, trying to get ready for this. There's so much potential and possibility from a K-12 mindset. It's a matter of us thinking about what skills can transfer over depending where the kids decide to go. So that's
Awesome.
part of my excitement.
Awesome. Mr. Walker,
Want me to jump in?
what excites you?
Yeah, I'm excited that the conversation is being had at scale now, right? Years ago, like I'm the person, the people like me are trying to drive these conversations, explain why it's important. I'm happy to see now that certain policies are being put in place to allow for these type of programs to happen. And in a lot of cases that funding and things are tied to it as well. I think the issue that, I mean, trying to find a way to do it at scale, I think is the challenge, but at least it's being talked about and we know it's important. And I think that also the fact that, there's been a push a long time focused on having skills and how you apply them. The fact that the career and workforce conversation is tied to this now, I think that's pretty exciting as well. And I think for us, as an example, I can't mention who it is, but I was in front of a really big brand this past week. And this brand brings in 40 high school kids a year and primarily focus on getting jobs in like hospitality and things along those lines. But now we're talking about how do we help those kids get these type of skills as a part of that internship to build products while they're working there to become employable and leverage tech and data as a part of their daily life. That conversation was not being had years ago. And I think that that's going to help us now tie local partners and brands to this conversation so that as these kids get these skills, they can also find employment to sustain their livelihood. So that piece excites me quite a bit.
Wow, that is exciting. All right, so I see a few questions that are coming in here. So first, I see Dr. Brian Cox, one of our colleagues from Georgia Tech and former administrator at the Georgia Department of Education, was with us. How do we leverage existing technology, programs, and policy to ensure all students are exposed to data and computer science? That's a big one. All right, would either of you care to take a stab at this question? How we leverage existing technology, programs, and policy to ensure all students are exposed to data science and computer science?
I guess I'll stop. I thought Ms. Wright was going to jump on that, but I'll take a
I
stab.
was, but there was a random phone ringing over here. I was trying to figure out where it was coming from.
Okay,
But
well,
go,
let
you
go
go.
first then.
I'll tag team.
Okay, cool. I was going to say, well, the cool thing about that one, I think Ms. Wright mentioned it, and Dr. Cos knows from some of his previous work, like the fact that we now have these educational standards that are out there that attack some of these problems from a policy perspective, that is huge because unfortunately, if you're looking at things that happen in the classroom, they're not going to be prioritized if it's not something that's being measured or being reported. So I think that infrastructure in place is really interesting and really cool to see that in place. So to me, that's probably one of the biggest things that's there. I think more policy though is needed to figure out how do you put these things at scale. And so we have these goals that are out there on the statewide level, but how do we enforce, people that are making some of these decisions don't necessarily have the technology background or the data science background. So finding ways to ensure that their advisory boards, their committees, people that are driving things that are measurable are part of that conversation, to me is something that has to be addressed and really thought through more. But I'm glad that piece at least is in place so far.
All right.
Oh, go ahead.
Go ahead. Yeah, no, go ahead. Go ahead. I'm sorry.
But two, I'm thinking of part of Brian's question about existing technology. Part of the uniqueness of what's happening is tech is evolving at such a rapid pace. Like Mr. Walker's been working on something for some years now, trying to get it to fruition. And there's so many things that, yes, we have robotics. Yes, we have drones. Yes, kids are learning to write code, read code, fix code. They're doing all sorts of things. We have them problem solving on B-bots and indie robots at kindergarten, first grade, and pre-K. So the tech is coming, but schools historically have been behind. So the more we can have conversations where the innovation and the research that's happening in labs and in different campuses and spaces, the more we get to peek into that, the better it is for all of our kids. And again, we're hearing more that companies aren't looking, and y'all can tell me if I'm wrong, companies aren't necessarily looking for content knowledge in everything. They're looking for, are you employable? Are you willing to learn? Are you willing to go to class? Will you come on time? We're hearing more and more about that in these workforce conversations. And it's about those success skills, because in DeKalb, we don't say 21st century skills because we're already there. So what you'll hear from us is kids having those success skills. But getting back to Brian's question, I think the tech is so far ahead right now. In some spaces, we're just trying to catch up and give kids the knowledge that they'll need to address what's coming, and also to help them understand the connection between content that they're learning in the classroom and be able to apply it to what's coming before them in the future.
Wonderful. We have a couple of follow-up questions, and I think you can take these two in one, probably, Mr. Walker. So Ms. Carla Willis asked, please give more details about how your after-school program would work in an elementary, middle, and high school. And then as a follow-up, Ms. Elizabeth Storkel asked what math concepts teachers need to know to help students with these projects.
Sure. Yeah, so I guess, so in our scenario, we build programs that really are help to support the program provider. So in one case, I mentioned my nonprofit, we run programs in several schools now where the whole point is that we go into the school, we see what their needs are. Typically, a lot of schools have themes. And to Ms. Wright's point, you want to be able to have those kids understand why they're learning something. And so we'll go cater a program that has a certain amount of time, working on these theme projects over time, but there's always a core approach with that. Whether it's elementary, middle, or high school, they're going to work as a team, they're going to solve a problem, they're going to apply some tech, and they're going to present out and speak why. So we're building recitation, we're building capacity, we're building content. And we also then, as a part of those programs, no matter what your age demographic is, we bring in external partners. So if we're talking about robotics as an example, you're going to meet somebody who does that in real life. We had some kids, we were working with some schools, one program recently where we were talking about data science and how to control systems. So I brought in one of my friends who was a principal program manager at Microsoft, who was a diabetic. And he showed them how he hacked an insulin pump to manage his insulin in real time. And the kids understood that because a lot of their, unfortunately, family members were diabetics, right? And so you find these problems that they can understand and react to and get them to use that. But definitely recitation, hands-on, and applied with a theme so they can kind of see it. So everything has a capstone type approach to it. As in terms of the skills, math concepts, whether it's robotics or coding, everything is really about computation and problem solving. So understanding kind of cause and effect. The math piece is typically a challenge and a burden in a lot of cases, but if it's done right, we walk them through that. I think part of the mistake with the harder sciences, people treat it in the classroom like you do in a grad school, where it's almost like you got to be smart to figure it out. We kind of reverse that in that you always get a win with us. Like the robot's going to work, the pump's going to move. We just help you understand and do the piece you understand, so you always get a win. And as you matriculate through and kind of grow in your progression, you unlock more of doing that. So you're never going to fail. It's always going to work. You just unlock more insights based on your capability and your skill set. And the assumption to us is that if I get you solving this problem and understanding kind of why, how stuff works, it'll motivate you to figure out why stuff works. And so that's kind of how we approach things.
Yeah, wonderful. And I've seen a lot of it in action with many of our school partners. So it's amazing to see students be able to apply many of these concepts in a hands-on fashion, and even for them to be able to guide their own learning. So yeah, amazing work that you're doing. Next question we had from Ms. Carla Willis for Ms. Wright. What types of training and hardware supports are available for STEM teachers in DeKalb County schools?
Great question. They will tell you that I send out an email almost every week of resources. Our community is rich in information. Let me just say that. So part of what Mr. Walker referenced made me think about one of the things that we're constantly looking at. We're looking at the correlation between what you're asking me to do in math, what you're asking me to do in engineering. It's the same thing I'm doing when I'm going and applying the engineering design process, design thinking with the mathematical practice standards, as well as the scientific process. So as you're asking me to ask and imagine when I'm approaching a problem or a project, I'm also attending to precision with math. I'm also making sure that what I'm doing is research-based. So I'm looking at what research is out there. So some of it is educating the teachers so that they're knowledgeable and comfortable before they get in front of the kids. Other trainings are things more from a STEAM lens with the arts and arts integration. So we may work with the High Museum or the Alliance Theater to look at how we can make learning more engaging or use some of the skills that they use in acting or performing in presentation. Because one of the things that we're noticing is that kids aren't used to presenting because they're constantly on a device. They're not used to having the conversations that we would have had in our neighborhoods growing up when we grew up, because they don't necessarily go outside and have those same conversations. So we're working on presentation skills. Teachers are getting trained on those robots. Their favorite thing right now is the Indy, and this is not a promotional video. But all the robotics, everything that you can think of that you would want in a school, we probably have a little bit of that. Now, we're not going out of control. I do have a limit, but there's a little bit of everything in all of our schools, and the teachers have to be trained on it in order to put it in front of the kids. So training on tech, training on pedagogy, training from university partners so that they can understand what's happening in those spaces to make the connections to what we're doing. They get a training on a little bit of everything. I think that answered the question. But yeah, we have a little bit of everything when it comes to training, the tech, the hardware. It's a little bit of everything.
Wow, that is amazing. And then I've seen a lot of that exciting training happening across the district. We have another question from Dr. Cox. Do the elementary school students you work with know they are learning data science, or is it couched within the other topics like math, science, or computer science?
Yeah, I can address that. I think when we work with schools, like things when we've done, most of the times our presentation is from a particular class. So like last year, one of our schools, we were doing the hands-on learning as a part of the computer science class. And so in that scenario, we made sure that whatever we did was themed around whatever that topic was. But within that, though, we try to expose them to the different ways in which this stuff is applied across industry. So we do try to broaden it so they understand the various fields that are connected to it. But oftentimes it depends on the lens in which through which we're presenting the program. When we deal with our things that we run completely ourselves, like our summer experiences, where we get kids for 3, 4, 5, 6 weeks, as a part of that conversation, they're exposed to everything, but we run deep and they get more breadth and depth, in that because we control the whole experience.
Ms. Wright, is it explicit in DeKalb County schools that students are studying data science, although they're not required to this year, but I guess they will be next year?
So I would say, because when I heard you read the question, I would say no, they don't know they're doing data science. They are learning components of it. So that when they get to that point, they'll understand, oh, wait, I already know a piece of this. Yes. But do they realize they're doing it? No, they don't.
All right, well, I know that we're partners so that we'll be able to make that more apparent in the very near future.
Yes.
All right, we have time for one more question and then we're going to have to close out. This question is from a graduate student at an undergraduate researcher, rather, at Kentucky State University. He says that Muhammad Lowe, I research IoT and cybersecurity. I also enjoy mentoring STEM kids. What advice would you give me to better serve my mentees who have a passion in multiple disciplines in our computer science and data science field?
And yeah, I'll address some of that. I don't know if the students are undergraduate or younger, but I think that's the one thing in that we're using a lot of adjectives to describe this work. And so in real life, it's all the same, right? I don't go to work thinking that I'm working in data science, computer science, or electrical engineering, mechanical engineering. So I think having them realize that you can like all of these things. The key is to find a project or something you can work on that addresses each individual component so you can see which one you like more, right? So the advice for me to be able to find some things you can do that get them exposure to it to figure out where they belong versus like when I chose, like what's cool about, you asked the earlier question about K-12, like when I went to high school, I went to an engineering magnet school and I had to choose if I was going down a mechanical path or the electrical path for engineering. I had no priority around that. I chose electrical engineering in high school as a pathway because I had installed a ceiling fan in my house, right? So that's why I chose that. It just happened to be the right one. But you fast forward, when I went to grad school, instead of choosing computer science, computer engineering as my focus, even though I was in EE, I chose power systems because I had no background. So I say getting them exposure to examples, understand these things, having them apply it and try it will help them kind of build their curiosity. But I would also stop looking at everything as being mutually exclusive because they all work together in the real life in the end.
And I don't know if the STEM kids you are mentoring are in college as well, or if they're in high school. But if they're in high school, I would say let them explore, kind of like what Walker said, let them explore their interests. But we have CTAE pathways or CTE pathways, depending where you are, for a lot of this, where they can explore their interests and then potentially leave with those credentials in high school or be or kind of have a dual certification and get their high school diploma as well as some credits if we're partnered with a college or university on the back end. And then I see something about access to training that I guess I mentioned. A lot of the trainings are coming from our partners, university, college partners, community partners like Woodruff Arts Center here in Atlanta, which houses the High Museum, the Alliance, the Symphony, all of those things. So we definitely utilize our partners for a lot of it. And then a lot of it, our teachers are certified and have become experts. So like I'm a Microsoft endorsed, I'm a Microsoft Innovative Educator. So we go through some of those trainings and opportunities for free as well and kind of cross-train each other. Oh, thanks for
Excellent.
clarifying. Yes.
Excellent. Well, we're at our time. And again, I would like to express my profound gratitude to Ms. Wright and Mr. Walker for taking this time to spend with us this afternoon, and to all of you in the audience who joined us and asked these insightful questions. We look forward to restarting our DS3 seminars next semester. And for to you joining us again, thank you, Ms. Walker. Thank you, Ms. Wright and Mr. Walker, for joining us this afternoon, and thank everyone that joined us this afternoon for our DS3 seminar. And we will see you again in the future. Have a wonderful weekend.